Welcome back to the LearnRHEL YouTube channel. Uh, this is intended for the audience of those users who are trying to develop their skill working with Linux. This will be actually a beginner level video, and it's actually targeted for those who are trying to work with the the Red Hat Enterprise Linux variants, so RHEL or ALMA-Linux or Rocky Linux and so on. If you actually are using Ubuntu, you might get something out of this, but please be aware that you are not the intended audience for this video. Thank you. So moving forward, I'm going to demonstrate how to work with the top command on a Linux environment. And I'm going to go ahead and log into my system here. And you can see that I'm already running the top command, but what I'm going to do is kill this screen and just get back to the root. You can do this whether you're root or not. So let's go ahead and exit out and go back to a general user command. And the things I want you to be aware of is, let's first, again, start by running top. I'm doing it as the user W French. And there are different sections here where you need to be aware of. There's this section up here. This is the summary area where you can see the summary of all the statistics of what's going on. You'll see the present time of day. You'll see the uptime since the last reboot, how many users are presently logged in and doing things on the system. So it could be the root user or it could be myself, in this case, W French. The load average, which means how much of the CPU by 100% is being taken up on a given 1 minute interval, 5 minute interval, or 15-minute interval. So not much is going on here. You can see the tasks and how many there are. Now, tasks and threads are different things. Just be aware of that. There are 233 total. 2 of them are actually running, and 231 of them are sleeping. So you got to realize that the operating system has a kind of a built-in scheduler, and this is telling you, hey, there's 238 total right now. 236 of them are sleeping, and the scheduler is doing that because there's 2 running, and nothing's saying, hey, give the stuff higher priority. There's nothing stopped, and there's no zombify processes. What's cool is that there's not been much for zombify processes probably easily in the last 10 years. If you see a zombie process, most of the time it means that you have subtly bad hardware. You might have a CPU or RAM that's not performing as well. Maybe it doesn't have a good connection on the motherboard. Perhaps not very well written software. I mean, there's all kinds of reasons why zombie processes occur. All right, CPUs. Now, this is the total usage of the CPU. So 6.8% of the user space, 1.3 of the system. Nice, which actually relates to this column right here, the NI column. Idle, which added up all together. All of these values here should always equal up to 100%. All right. And they're basically representing these in full percentages. Just imagine there's a percent sign after them. And then there's how much of the RAM, that's this part right here, being listed as memory, right here, being listed as memory, and then swap. Now, swap is a part of disk space that could be allocated either by a full partition or by assigning some space to a file, in quotes, calling it a swap file. And then applications in the old days, as far back as 10, 12, 15 and older years ago, they would use more RAM than was available on the actual motherboard. That's this column. But swap was there to offer a little bit more space for working space for applications and CPU to work together and do some partial process, hold this value out of the way, do another partial process, hold that value out of the way, come back to the final equation, take those 2 parts from swap, put them into the equation, calculate, execute, and move on. All right, that's the best way I can explain it from an analogy. All right, finally, we have the header line, which is this one right here. I'm treating black from the white bar that's on it. And then the task section, which is all the way down here. It's all of this. And you're not seeing all the tasks. You're seeing all the tasks up to the bottom edge of the screen. And I can't give you any more screen. As you can see, my scroll bar is all the way down. And that's kind of how the application works to begin with. All right, so some of the things I wanted to show you beyond this is, oh my God, I run top. How do I get out of this thing? You can hit the letter Q. You're back to your terminal. You type top again. If you're running top and you want to do something else, you can hit Control C on the keyboard. There you go. You've killed the top. And that handles that. And then I'm going to run top and show you how you can start modifying the way the screen looks. So the first thing I want to do is change the way the memory usage is presented with the units of measure, meaning the megabytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, and so on. And so the way we do that is we're running top, and this is interactive command as opposed to a command line switch. We're going to run top like we're doing, and then we basically hit capital E. So we have to hold down the shift key and hit the letter E on the keyboard. And you can see here that we just changed from megabytes to gigabytes. If I hit capital E again, it changed from gigabytes to terabytes. And you can see this kind of scales up or scales down the number value here. Petabytes, 0 petabytes. So I don't have that much RAM. This is a virtual machine. EIB is for exabytes, and then hit it one more time for capital E. We go all the way back down to kilobytes. And this is, a representation of how much RAM is actually being allocated to the virtual machine, or if you have a physical machine, how much of the RAM is actually available total of the machine. If you think you have, something like, I don't know, 16 gigabytes, and you're seeing a lot less than that when you get to this level, then maybe you might have a RAM DIMM that's kind of bumped loose from the motherboard. Believe it or not, that actually happens, even with all the clips and the little channeling and all that stuff. So as a newbie, learning how to deal with Linux, learning how to deal with operating systems, learning how to deal with hardware, you have to be aware of the fact that how much RAM is actually on the motherboard as opposed to trusting somebody. And then analyzing the operating system to determine how much is the RAM is actually being presented to the operating system. That's a disconnect. How much is physically plugged in might actually be how much is being presented to the operating system, because again, that RAM DIMM may have popped loose. And this has happened many times in those environments where you're dealing with high performance computing. All right. So I've taught you the letter capital E command, and now what I'm going to do is teach you about how to scale the units of memory for this area right here. So we hit the letter E lowercase, no shift key, and you can see now this is presented in megabytes, and now in gigabytes, now in terabytes, petabytes, and we're all the way back down to kilobytes again. All right, so we've learned how to toggle the presentation of RAM and swap in terms of kilobytes, megabytes, gigabytes, terabytes, petabytes, and exabytes. We've done it for the tasks right here for basically these 3 columns of data. And then the next thing we're going to do is talk about how you can change the way this is presented, more of a status bar or analog scale of how much is being used out of how much is available. So the way you can do that is by hitting the letter M on the keyboard, lowercase m. And so we change this right here. And it's either that or a full actual bar or nothing or back to the original. That's the letter M. We will cycle through. We now see a bar with like pipes represented versus actual white rectangles all next to each other. And don't forget to look right here, by the way. This is also helpful to you. Or nothing. All right. So then after this, one of the cool things I wanted to show you is how many CPUs have how much load independently. Well, unfortunately for my video, I can't do an excellent job of this because I've only got one virtual CPU allocated to this one virtual machine. But I'm going to hit the digit 1 on the keyboard up by the tilde in the upper left corner. And right now I actually see percent of CPU 0 presented. If I had 32 cores or 16 cores or 8 cores, I would have CPU 0 through, let's say for an easy count of 8 cores, I would have CPU 0, 1, 2, 3, 4, 5, 6, and 7. And these columns would not all perfectly align in terms of numerical values. We'd actually have different numbers listed across the span of the range of CPUs being presented. So I'm going to hit one again, go back to the standard look. So this is percentage of all the CPUs versus CPU 0 specifically. And again, I'm running a virtual machine. Hitting 1 doesn't really make any difference. And then now the next thing we want to do is modify the frequency. How often does this display update? Take a look here real quick, just for the sake of learning. That's on the 28th second, 31st second, 34th second. We can change that frequency by hitting the letter S, and then we can say, hey, let's change this to every 2 seconds, and then you hit the Enter key. Okay, and then watch for 47 to 49. Oh, sorry, 50. Then it should go 52. Something didn't work. Maybe I have to type 2.0. Okay, there we go. I had to hit the letter S, and I have to actually type 2.0 on the keyboard, then hit Enter. Last time all I did was hit 2 and hit the Enter key. I was actually expecting that to simply work, but I just learned something with you. And that's all. I mean, that changes how frequently the update. Maybe you want to check every 10 seconds, so you can do 10.0 and Enter. So this screen will not update again until it's 4:08 and 43 seconds. And it just did. All right, I'm going to set this back to the default. And I'm going to hit S and 3.0, hit the Enter key. We should go back to every 3 seconds now. And then the next thing I want to demonstrate to you is how to filter based on the user. So we got the W-French user, we got the root user, we might have postfix running, we got FA policy D and polkit and so on. So let's do that. You have to actually know, I think you have to know some part of the username. So I'm going to try you. I'm going to type in WFriend. My username is clearly WFrench in this case, but I'm going to hit the Enter key. And it says invalid. That's because I didn't type in WFRENCH to match the entire name of the user. So whatever you're doing in here, you need to know the full spelling of what you're filtering out. So I'm going to do U and then WFRENCH, hit the Enter key, and here we go. All of my processes for the user WFrench running on this given virtual machine are now listed or off the bottom of the window. Okay. So cool, we just learned how to filter, so let's try another one. Let's do all of root. I just typed in root right here. Not sure if you saw that before. And now we're listing only root. Now when I type U, this is basically called the message or notification range, I believe. We'll see better here in a few minutes. But yeah, you can actually specify that, or you can hit the Enter key and get them all back. All right. So then the next thing I want to do is try and toggle to show what path these things, hopefully, what path these things are running out of. So this might be useful if you're dealing with a hacker who might have done something kind of nefarious on your system and you're not aware of it. You know, they may have put a copy of some binary, a library, or more specifically an executable, because that's kind of what's listed here anyway, is executables. You may see listed and you say, oh, let's see, system D is running. But what if system D actually got modified by a hacker and they put it in a different directory to get away with it? To know that, you need to, one, know your own operating system, but two, you need to know what's actually running in the stack on memory in the top output. So we're on the C command, hit the C on the keyboard. It's an interactive command for top. And now I went gnome shell to user bin gnome shell, gnome terminal server to user live exec gnome terminal server. And then everything else that's basically a kernel kind of subcommand actually is wrapped in rectangular brackets, just so you know, okay? So you can combine that and do, like we did with, say, turn on the full path of commands, hit U, and let's say W French, hit the enter key. Now everything that W French is running at this moment, and with the full path command, you can see, oh, dbus daemon is actually run out of user bin. Oh, gnome keyring daemon is run out of user bin. Or pulse audio, which is actually the process that helps with running audio out of a Linux machine, that's running out of user bin. User live exec stuff, and so on and so forth. So this is pretty cool. All right. The next thing I want to show you is if you wanted to turn off the full path, you can just hit the letter C again, by the way. There we go. The next thing I want to show you after this, because again, you can hit every letter once to turn something on in quotes, and then a second time to turn it back off. Basically, you're toggling back and forth between 1, 2, or multiple phases. Just be aware of that. Okay. The next thing we want to do is maybe search for a particular task. See that Wayland, X Wayland? I don't see it now, but if I do Shift L on the keyboard and then type in X way and hit enter, I got away with it, by the way. This was just a partial string match that actually works as opposed to the username thing. But just typing in X way, you'll see X Wayland get lit up on this column when it shows up. Like that. If you want to focus on GSD power, let's do that. Capital L, GSD-power. Hit the enter key on the keyboard, and there we go. And it will pop on and pop off depending on the actual process list here. These are very cool things to know how to do with the top command. Very useful. Okay. If you want to actually modify the way this all looks, because it's kind of overwhelming when it's all black screen with white text or a white background with black text, you can actually change that. So the way we do that is we hold down the shift key, hit the letter Z on the keyboard, and we come up with this. This is actually kind of right here, this region here, shows you once you're ready and to go back to the actual top output, what your screen should mostly look like. So again, we got the summary data, and that's basically going to be from here to here. So let's go ahead and do S for summary, and that changed that to S, by the way. And then we're going to choose a color. So I'm going to go with the color of cyan. I'm going to hit the 6 on the keyboard, and it changed it. I don't like cyan, so I'm going to hit the, instead of doing 6 for cyan, I'm going to do 2 for green. And I did not have to hit the S again, but if I do something like hit the letter T for task information for this range down here, and I went, wait, actually, no, I want to change the summary data. Let me hit the capital S again. I can go back to that, and then I can choose a different color. So I'll choose 4 for blue. Check that out. All right, now in my preference, I actually prefer the color green, so I'm going to do that again. And then what I'm going to do is T for task, and I'm going to change that task information to the color of yellow, so 3. There we go. That changes all the commands and who's running them and how much system resources are being taken up. And if I want to change the header column, I'll hit capital H, so Shift and the H on the keyboard. And then I'm going to choose a different color. And for me, it actually makes more sense to make it white. It's your preference. You do what you want. But now I kind of have like a separator row of all the headers that I need to look at. And it kind of visually helps separate this stuff from this stuff, which is always showing, from this stuff, which is always showing. And then the nasty message or input prompt. That's the part where we were doing the letter U and typing in stuff, or the letter S and then typing in 3.0 or 2.0, or the capital L to go search for a specific binary running in memory. So I'm going to change the nasty message by doing the capital M, by the way, because it says here, it says capital M, but here it says nasty message. So capital M, you saw that change here, hopefully. And I'm going to change that to, heck, why not magenta? Is that a good color? All right, I like that. So now I'm done with all my little color changes, all silly as it is. and I'm going to hit the enter key on the keyboard, right? So I got the yellow down here. I got the search for GSD power still running. I got all the tasks in summary section up here in green. Maybe I don't want that. Maybe I want the task section to be more of cyan. Oops, that's not what I wanted. I want task section to be yellow. And I want the summary section to be cyan. Okay, I'm going to hit the enter key again. Last night when I was preparing this process, it was actually a different color, so I'm not sure what's going on. Capital Z again. And let's choose summary to be green. All right, there we go. Let's search for something else. Let's do a search for root. And now you can see that the search interaction prompt is presented in purple. And there you go. And I guess we're expected to believe that that's all that root is running, but I don't know. I think root is probably running a lot more. Maybe the kernel stuff is just not a part of this list. Okay, now, if you like these colors from the standard white on black background like we started off with, you can actually commit these changes by hitting Shift W on the keyboard, and then that should actually work. Let me double check W, and you can see it said here when I hit the W, it said root configuration. So now I'm going to do a Q to quit. I'm going to run top again, and hey, look, all my color scheme came back up the way I want them. And again, you can do this for yourself. You can change the colors to whatever you want for yourself. The top command, when you make those changes, are going to be saved to a configuration as you just saw, but for your account. So when somebody else logs in to the same account, though, they're going to be presented with the same color scheme. So if Tom runs top as Tom and Bob runs top as Bob, and they change color schemes, they will each have their own color schemes. But if Tom logs in as root, changes the color scheme for himself, thinking, hey, he owns root, not really. And then he makes the color scheme change, and then quits, and then Bob logs in, escalates privilege up to root, and runs top. He's going to end up with the color scheme that Tom set. So be aware of that. All right, and the next thing we need to do is what? Okay, no. Okay, now I'm going to show you how to do some really basic command line stuff with top. You can do top like this. Again, notice that the commands are all, short, no path. I'm going to do Q. I'm going to do top space minus C. So that's the equivalent to doing top, getting the top running, and then hitting the C on the keyboard. Because now you can see all the full path is presented, or that the kernel specific modules are actually bracketed, rectangular bracketed. Okay. You can see here that top is updating like every 3 seconds. Let's do Q. Let's do top space minus D. And in my case, yesterday when I did top minus D2, that worked. So let's watch and see if that works after the first couple of hops. 44, 46, 48. There we go. So the top space minus D, lowercase d by the way, and then the digit 2 will work. You can also do top space minus D space 2 by the way. Just like that. And that's all we need to do. All right. And then the final thing is, how do you run top looking only for processes from the user W French? Well, now you can see. Top space hyphen U W French will do the same thing as running top. Hitting the letter U, getting the prompt for what username, typing in the username and hitting enter. Okay, folks, that's all I wanted to show you. If you want to learn more, the best thing you can do is always run the man page on the command you're trying to learn. And here we go. So you can run through here. You can go through the command line options, which is where the minus D and so on come in. You can get down here to learn about load averages and task CPU states and all the meanings of all the statistics you're seeing on the screen, and memory usage, and field columns, and how you can kind of either rearrange them or kind of filter them out so you don't see them while you're looking at them. Getting further down, these are all the fields still. And interactive commands. So the capital Z for color changing and all the other stuff you can do. All right. 0 through 7 for the colors that they have identified, L for searching, and so on. All right. Just remember that the top command is not damaging. It is not writing anything to the operating system except for your own user directory to save that profile with that configuration. Okay, cool. This is the end of the video, and I really appreciate you guys hanging out with me and checking up on my YouTube channel. Thank you very much.